Now, square roots, we're going to call them radicals because it could be the cube root, it could be the fourth root. We're going to deal this year with square roots only, but radicals we know are perfect squares, such that, square root of 4, we know that's 2. Square root of 9, we know that's 3. Square root of 16, we know that's 4, and so on and so forth. We know the perfect squares. I'm going to separate my radical into two radicals, so two square roots, such that one of them it's a perfect square. So for example, square root of 490, I'm going to split that as the square root of 49 times the square root of 10. I know square root of 49 is a perfect square, so this thing simplifies to 7 square root of 10. Square root of 10, I cannot split it into two radicals where one of them is a perfect square. I can split it into 2 and 5, but none of them are perfect squares. So that's as simple as I can go. Square root of 8, I can break that as square root of 4 times square root of 2. Right? 4 times 2 gives me 8. And square root of 4 is a perfect square. This becomes a whole number 2 with radical 2. I can multiply a whole number with a whole number or a radical with a radical, but do not mix and match. Now here, question number 3, I'm just looking at the radical to begin with. Let me go 147. I'm going to split this as 49 times 3. So I'm going to go radical 49 times radical 3. So 49 becomes a whole 7. So that's a whole number. I have a whole number on the outside to begin with. And remember, I just said whole number with a whole number, radical with radical, do not mix and match. I'm going to multiply the whole numbers. 10 times 7, that gives me 70. Radical 3. Looking at square root of 48, I'm going to split that as square root of 16 times square root of 3. I'm thinking of two numbers that multiply equals 48, such that one of them is a perfect square. Square root of 16 is 4, so that becomes a whole number. I have a 9 on the outside to begin with, so 9 times 4, that gives me 36, radical 3. So if there's a number on the outside to begin with, don't forget to multiply your whole numbers. Now we're going to look into division. What if I have a radical at the bottom to begin with? Let me simplify this a little. I have my 2's cancel out. Now I have a radical at the bottom, and my rule is going to be no radicals at the bottom. So the way I'm going to get rid of it, I'm going to multiply top and bottom by the radical from the bottom. So this case, radical 6. So I have radical 90 over 6. Now, radical 90, I can split that as square root of 9 times the square root of 10. So that becomes 3 square root of 10 over 6. I see my fraction, 3 over 6, that can be simplified to radical 10 over 2. All right, let's take a look at number 6. I'm going to multiply top and bottom by the radical at the bottom. So I have square root of 15 over 3. You guys might be like, well, how did that become a whole number? When we squared a radical, that's technically radical 36 on question number 5. Square root of 36 is 6. Number 6, that's basically the square root of 9. Square root of 9 is 3. When we squared a radical, we just get the number on the inside. All right, let's take a look at number 7. Multiply top and bottom by square root of 5. So I have the square root of 15 over 5. Square root of 15 I cannot simplify, so that's good. Looking at question number 8, I'm going to multiply top and bottom by the square root of 3. So to begin with, I have 3 radical 3. Square root of 3 times square root of 3 is 3. There's a sign in front of my fraction. I see that I have a fraction, 3 over 3. Basically, they cancel out. So my answer is negative square root of 3. Your rule is your radicals, your square roots should be as simple as possible. And if you have a fraction, no square roots at the bottom.